Hello everyone, and welcome to the 99th Melbourne AWS user group, and our final one for 2020. Will this be our final lockdown one? Who knows? I don't even think Dan knows that yet. But the signs are all promising, and we've been doing this since March, so hey, maybe next year we'll be able to catch up in person. That'd be really good. But until then, we've got two great presentations coming up for you tonight, so let's get right into it. So we have our agenda for tonight. We have our usual introductions, which is the segment I'm doing now. Right after me, Arjen and Guy will take over and run through what's new in AWS for the last month, and there's been some really good things in there. I understand Arjen's been updating slides frantically throughout today, trying to keep it up to date. Then we have our first presentation after that. Isaac and Nick will be taking us through the evolution of their golden image pipeline over at the Australian Bureau of Statistics, so this should be really interesting for everyone. Then after that, we have our second presentation. We have Sean and Matt will be taking us through scaling up and down their bill during COVID-19, which I'm sure something that we could all use a lot of advice on, given we're all facing similar circumstances at the moment. We'll wrap up after that. And as usual, we have a post-stream Zoom catch-up that we'll post the link to in the Slack if anybody wants to join in on that. So the format for tonight, I think this is our sixth or seventh time we've been doing this. So the format hasn't changed, but just to run through it again anyway, if you're new around here, welcome along. We do ask you to ask any questions or that you might want to ask of the presenters. You're welcome to jump them into the Slack channel up there, the #Melbourne Slack channel, on Twitter using the AWS Melb hashtag, or in the YouTube chat as well, right where you're watching. After each presentation, myself or Ian will jump on the broadcast with the presenters, and we'll ask those questions on your behalf. And we encourage you to leave any comments you have too, any comments or feedback throughout the night. The chat doesn't just have to be any questions you might have for the presenters. Please feel free to discuss the topics as we go along. And of course, we definitely welcome any feedback you might have for ways we could improve this event or get people more involved, that sort of thing. Any and all feedback is welcome. But we would be remiss to go any further without mentioning our sponsors, in particular Enabler, who has been our gold sponsor for the last 2 years now. They, like our other sponsors, have stuck with us even though things went weird. We stopped hosting events in person, that sort of thing, but they've stuck with the community and they've continued to support us and everybody through this year. So huge thanks to those guys. Likewise, our silver sponsors, AC3, CMD, and Do It International. A big round of applause for those too if you're at home. Thanks to everybody. So just a quick overview of who we are. My name is Rob. I'm at Bok on Slack or at Bok _ on most other platforms you could find. And my co-host, who you'll see in the top left-hand corner or top right-hand corner when we switch over to the news, is Ian. So neither Ian nor I nor any of the other 4 volunteers work for AWS. We're all just members of this community, the same as you. We work in the AWS industry day in, day out, and have done for a long time. So yeah, feel free to voice any opinions you might have of AWS here, because we're all just community members. Like, we don't have to, toe the company line or anything like that. Not that AWS tries to force us to or anything, but we welcome all opinions here. You want to say something about how Azure is better than AWS at certain functions, that sort of opinion is welcome here. Especially feedback on how AWS can improve too, because that's useful for everybody. I lost my clicker. So if you do want to get involved, I highly recommend you join our Slack channel or our Slack team. There's about 600 members or so last time I checked. We have a bunch of channels, but it's a great place to ask questions. Like, if you get stuck on things, discuss the latest AWS news. If you're looking for work as well, we have a jobs channel in there, and a few other channels as well, with some bots that like post outages and announcements and things like that to foster discussion. And that's a great segue into if you do want to get involved, we're always looking for people to help. We're always looking for speakers. Even though this is our last regular meetup for the year, we're already looking for speakers for 2021. Always looking for sponsors as well. If your company's interested in sponsoring, we do annual sponsorship, and so our value proposition probably needs a little bit of work for next year. But if you are interested in sponsoring, just let us know. And we're always looking for volunteers too, big or small. There's lots of jobs that need to be done. So just jump into the volunteers channel on Slack. Okay, so before we get into our own content, just a quick look at some of the other things that are coming up that you might want to check out. Primarily amongst them is this coming Friday, so 2 days from now, there is a AWS User Group Summit for Australia and New Zealand. This seems to be our 3rd or 4th community day that AWS has promoted this year, but that's a great thing, because that means there's a lot of great content from the community members here in Melbourne and in Sydney and the other states around Australia, and New Zealand as well for this one. So it kicks off about lunchtime on Friday, and I think it's just a 3 hours of power sort of deal. There's a lot of great speakers listed. Check out the link down the bottom there for the agenda and for the registration. It looks like it's going to be a great Friday afternoon. And then there's this other conference that I think you may have heard of before, but if you haven't, it's basically the usual week-long reInvent that Amazon hosts in Vegas, but spread out online for 3 weeks, starting next week. I don't think I can summarize any of what's going on in there. Jump on the website if you're interested at all and you haven't already, and check out the schedules, because there's quite a lot of things going on, and all sessions are repeated. I think most sessions are repeated 3 times for the 3 different time zones they're targeting, and one of them is the Asia Pacific. So there's a very good chance that the session or sessions that you're interested in are on during hours that are reasonable for us. And I think that's the last of my slides. Yep, back at the beginning. So we'll throw over to Ian and Guy for what's new.
Hello everyone. Yes, we've got a packed new segment today, as Rob said, with reInvent coming up next week. It seems that AWS has been doing their best to dump everything that wasn't good enough for the keynotes in the past couple of weeks. So I think just today alone we got about 40 new announcements. So
but they weren't all junk, were they? there's some good announcements in there, some exciting stuff.
Just because they didn't make the keynote doesn't mean we are not happy about them.
That's right.
But with that, let's quickly go through them. It might take a while. First, of course, finally in Sydney.
Yay!
Yay! So we've got two services, Kendra and SageMaker Studio, improvements to an existing service, which is IP multicast in terms of gateway, and a new hero in Australia, a data hero, Denise Bauer.
Woo!
Always
We
good.
like heroes.
Yep. Summary, Kendra is more an enterprise search engine that does everything that sources from different sources, so you can hook it up to your Confluence or Salesforce or things like that.
Yep.
SageMaker Studio allows you to build your SageMaker things.
Things. They're just machine learning magic.
Yep. And IP multicast is for broadcasting of your transit gateway. So
yeah. So it's got use cases for media streaming and such like, any kind of real-time streams and things. Yep.
Exactly.
Awesome.
And then we get into the meat of all the new things.
Yeah. Code signing. You're a bit excited about code signing?
Well, I'm not particularly excited for myself, but I can definitely see use case for it. So Lambda code signing was announced yesterday, so I haven't had a chance to play around with it. But in theory, what it allows you to do is make sure that your Lambda only runs the code that you have signed off as being good enough. Similar in a way to, if you're familiar with that, how you can have signed containers running.
Yep.
So
that's one for the compliance bods. They'll be happy about that, I guess.
Yeah.
The batch windows for SQS event sources. So batch windows for Lambda for Kinesis and DynamoDB came out in 2019. So now there's batch windows for SQS as well. So what that lets you do is batch up essentially up to 5 minutes of SQS messages, I guess, in a and handle them as a batch rather than sort of handle them individually.
Yeah, that can definitely have some good cost savings, I think.
Yep, especially you've got a very chatty SQS queue with lots of events coming through.
Yeah.
Yep.
Step function synchronous express workflow.
Yeah.
This one.
Yep. This is neat. I'm a big fan of step functions. It's got a couple of updates in this set of announcements. So API gateway integration, EKS integration, so you can talk directly to those services with step functions now, and the synchronous express workflow. So usually step functions is asynchronous, right? So you kick off an execution of your state machine, and off it goes, and it does its thing, and it finishes whenever it finishes. And if you wanted to find out what state it was on, you could query it, but you can't. There was no kind of synchronous response. Now you can put API gateway in front of it and ask step functions to execute and get a synchronous response back. So for in the single request, which is neat. So potentially making it useful to do things like build web applications where you send a piece of data out and you want to get a piece of data back in response. So that's going to be a very interesting capability that's been brought to step functions, I think.
Yeah. Definitely sounds like great functionality.
I think the other nice one here for developers who wanted to maybe use Dynamo but were too scared to figure out how to actually use it. You've now got some support for a SQL, querying it with a SQL compatible language called Particule. how would you say it? Particle?
I think it's
Anyway.
supposed to be particle.
Yeah. So I'm sure there's a lot of developers out there who'll go, oh, thank goodness. I know how to do SQL.
Yeah, and in case you're not familiar with it, Particle was, I think it was announced by AWS last year or so, and they are slowly building that in across all their services so that there's a common language you can use to do queries across everything.
Yeah. Neat.
Yep.
And EventBridge?
Yeah, EventBridge, event replays is pretty cool as well. This allows you to, instead, up until this was released, if you got a message through your EventBridge, say you hooked it up to an outside source, if something failed, then you were out of luck. Now you can actually cause it to replay this event and see if it goes through that time. Yeah. I suspect that might be very useful while you are either debugging or developing it in the first place.
And those events get stored in S3, I think. So
yeah.
there's some cost associated with the storage of the events that you want to be able to replay. So I guess you've probably got some lookup to do on the cost table to figure that out.
But let's move on because we've got.
So aren't you going to mention Code Guru Profiler? I thought you would bring out your Java Labber.
By accident.
Oops.
For containers, the big news here is probably Lightsail containers. If you remember what Lightsail is, that is the way of running EC2 instances that is not really part of the rest of the AWS world. So it's a completely managed service where you can say, spin me up a WordPress service. Now you can do this as well for containers. You upload them or have them on local hub, and it will run them for you. We'll put a load balancer in front of it, and you can scale it up to a fair number of different containers.
It's probably something it's got a quite good low entry point. So, like you said, you've got a load balancer and you've got high availability for your container workload, and it's quite cheap. I think was the entry price about $7 a month or something for one container workload. So probably quite good value for that. Probably less good value if you're wanting to do something more major. And you are sort of stranded in Lightsail land once you go down the Lightsail path. That would be the only other thing to say, maybe.
Cool. But DevOps CloudFormation modules just dropped basically this afternoon, around lunchtime, I think. And it allows you to build modules for your CloudFormation. Again, I haven't had a chance to dive deep into this yet, but from my reading, you can build a CloudFormation template, upload that in a special way, and then you can call it from your regular templates. If you like Terraform, think of it as you would Terraform modules. So,
and the main sort of use case of this is if you wanted to wrap up some sort of best practice type configuration of a service and have it produce it as a module so that it's kind of easy to have other people consume that module and you know that it's going to be configured correctly. Is that the sort of is that one of the use cases for it?
Yeah, that and making it easier to do repeated tasks.
Yeah.
So it seems very interesting, and I will definitely play around with it. Also to see how it stacks up with all the other CloudFormation, just like macros or custom resources.
Yep. Just refer to Ian's Twitter. posts about that.
Yeah. About 10 different ways to do this now.
That's right. Yeah, CDK being one of them, of course. Yeah, that's right. Change sets.
Yep. Also a big thing. You can now, if you use nested stacks, you can finally actually see what changes when you create a change set. Before, all you could see was this template or this substack is changing. Now you can see what actually changes there, which is a major improvement in usability.
Yep. X-Ray supporting S3, so you can now trace requests that are going to S3, which is neat.
It's neat. But
oh, here we go.
Security, some of the other big ones. First off, because I always like to talk about it, AWS SSO now has additional identification methods for the second auth. So you can use UTF things like YubiKeys, but also for biometric scans like Windows Hello or Touch ID on your Mac. When I tested this, it didn't seem to work in Safari for the biometric stuff, but it does in Chrome. I don't know what's going on there, but that's an interesting one.
Yeah, enforce MFA on first login's neat too. That's
That was on my list for a long time.
Yeah, that'll catch all those lazy buggers who don't want to put MFA on, right?
And it also means that you can now enforce MFA because after people log in for the first time, they will be forced to set it up, and you don't have to do it for them.
Yep.
So all good.
Yep, all good. Network firewall.
That's
How long have you got?
I think this is the biggest announcement so far. Basically, this allows you to set up a firewall inbound and outbound with URL whitelisting and all the fancy stuff that you would want on your VPC. And of course, you can then use Transit Gateway to filter everything through that VPC so that you have different connections there. As Guy jokes, we can talk about this for a very long time. If you're interested in this, I would recommend some blog posts or
listen to the podcast.
Listen to the podcast
when it comes out.
Last Friday and will probably be posted tomorrow morning. So go in way more depth on this there. We don't have time for that.
Yeah, it's also integrated with Firewall Manager, right? So that's a neat thing too.
Other cool stuff. Almost forgot about it because it seems so long ago, but Nitro Enclaves.
Yeah.
This allows you to create a secure section on your EC2 instances and can be used, for example, and this is the AWS provided use case, to run your AWS certificate manager search directly on your EC2 instance.
Do you think it's the easy way, though? Still,
I would recommend just put a load balancer in front of it.
Yes, I think so. Yeah, it's a lot to kind of do in order to achieve the outcome. If all you want is a certificate on EC2, as you say, put a load balancer in front of them and terminate SSL there. That would be a lot easier. But it's certainly an interesting technology that they've kind of released, and it's all part of the Nitro system, I guess. And it's always good to see how they're coming up with new ways of new power for us, I guess, to do things that we couldn't do before. So it's all good. Okay. Yep. Storage lens is probably the other big one there, Arjen.
Yep.
Did you say? Yeah.
This all gives you the insight into your S3 that you've always wanted but couldn't have. Also
Yeah.
works cross account. So
Yeah, so I actually tried to get it set up across accounts yesterday, but didn't seem to. I haven't quite found the magic sauce yet to make that happen. But it's certainly very nice to have a dashboard with stats about which folders in your buckets and have got the most stuff in them. You'd certainly eye-opening. I think most people who open up Storage Lens will go, "Oh my God, what's all that stuff doing there?" And it'll be a good way of. There'll be a lot of people dumping a lot of dumping a lot of data out of buckets and deleting buckets. I think as a result of Storage Lens coming on the scene.
Yeah. Cool. And then we're out of time. So there's just one more I want to mention. Not all news that we care about here happens at AWS. So I would like to ask everyone to join me in congratulating wonderful host Rob, who is getting married.
You're punching above your weight there a bit, Rob, I reckon.
I didn't approve this message.
So, Rob, back to you.
Cool, thank you anyway. I appreciate it. Thanks, Ian. Thanks, Guy. That was great. Appreciate the shout out there at the end too. There's definitely a lot to get through there. And as Ian and Guy said, if you are interested in hearing any more about that, they did record the podcast for this month already. And it should be out soon, so definitely check that out. Okay, so on to our first presentation for the evening. We have Isaac and Nick going to take us through the AWS Golden Image Pipeline for the EC2 Image Builder. If you guys can share your screen for me while they're doing that. So Isaac is a computer security grad. He currently works in the Cloud Platform Operations team at the Australian Bureau of Statistics. He has been working on AWS at the ABS for over a year and a half now, striking to uplift their system's operation. And I don't have any information on Nick, so I assume he's just some form of cloud enigma. But I'm sure we'll hear from him over the course of this presentation as well. So without further ado, I'll hand you over to those guys.
About a month ago. Grad program was a lot of fun, but now I'm a permanent. Just from the start of this page. Awesome, thanks, Rob. Awesome. So I just wanted to highlight that I am actually new to the group. So I have been lurking for a while, and I thought I'd get involved with my coworker Nick Kiadas. Also, I was a grad at the ABS. I just finished that up about a month ago, and I'm now a permanent fixture at our Cloud Platform Operations team. Yay. I've been working at the ABS for about 2 years now, and working with AWS for about a year and a half now. In terms of training, I have done a Systems Operations Associate course, DevOps Engineering on AWS course, and honestly, I just feel like I could never stop learning. There's just way too many services and features that come out. I'm always almost overwhelmed. Personally, about me though, in my free time, I like to play a lot of video games, particularly Path of Exile when a new season comes out, or love to go climbing in Melbourne's local bouldering gyms now that they're open. So I'm going to let the Enigma Nick introduce himself, and then he's going to sort of introduce what we'll be talking about today as well.
Hey everyone, so I'm Nick Gerados. Not Enigma, I do exist. So been working at AWS now for just over 9 years now, and been through actually a number of teams. Actually did start as a grad, just like Isaac, and yeah, stuck around. So currently in the cloud platform operations team as well. Relative about 2 years of AWS experience. So still fairly new to the game, but yeah, I'm forever learning. Have been on a couple of the courses as well, and my spare time been trying to study for the SysOps exam. But when I'm not doing that, I do like to get outdoors, and when we're allowed to get outdoors, so I do a fair bit of cycling. Used to compete, not anymore. And yeah, now just trying to stay fit really, and traveling. But who knows when we're going to be traveling next? So who are we? The AWS. So the Australian Bureau of Statistics, we're Australia's national statistical agency, and our purpose is to inform Australia's important decisions by partnering and innovating to deliver relevant, trusted, objective data, statistics, and insights. Now, as you'll see, our release calendar here, it shows which statistics will be released on which date, and hopefully you can make out the red dots, but they're our main economic indicators, or MEIs, which are our most important releases. So for instance, this is what the CPI or the labour force statistics are classified as. Now, looking at the month of January, it looks like we have, I think it's about 10 releases due, and these statistics, which I'll explain, will also affect the consumers in the Australian stock market. So these statistics are released, they're then obviously consumed by our customers for their decision making. But what you might not realize is that indirectly, all of you are our customers as well. So to give you an example how statistics affect our customers. So we release a new CPI, or just unemployment rates. So then these stats will go in part with helping the Reserve Bank of Australia in determining what the interest rate will be. So if anyone here has a loan, well, this affects you as the interest rate affects how much you have to pay back. So these statistics also influence the stock market, which then affect the strength of the Aussie dollar compared to the US dollar. And having a stronger Aussie dollar compared to the US dollar, well, this affects how much you guys will have to pay for AWS services. So what you don't realize is that everyone here is our customer in some way. So this is where we started at an AWS. So we started in the new AWS Foundations team, which were meant to be setting up or creating the foundation space for the AWS. So as we had limited experience in AWS, we needed something that would expose us to the vast array of AWS services, and just to get our skills up to speed, especially as new applications wanting to migrate across. So we'll task with setting up our standard operating environment. So this talk is going to focus on setting up our standard operating environment and then how we turn them into AMIs. And I know that AMIs is a somewhat controversial topic, so whether it's ARMY or AMI, whereas we like AMI. So our standing operating environment. So we needed something that was secure, automated, was easy to use, and reusable for the different platforms. So as we had an application wanting to migrate across, I was on Windows. That's what we first started with. So it was a bit of a steep learning curve at first. This is where we learned how to template up in CloudFormation and play around with a lot of the services for the first time. And we kind of just focused mostly on Windows Server at first, but then we realized we needed an entire pipeline. So we needed approvals for if we wanted the new AMIs to come across, or also when they we want them to be scanned, and wanted to then notify the relevant areas of scanning. But we also needed other operating systems, and we had applications that wanted to come in on Amazon Linux 2 and on Red Hat, for instance. So then we're looking at other solutions, and we'll point to the direction of an AWS solution, which was the golden image pipeline. So I'll hand over to Isaac to explain that.
Awesome. Thanks a lot, Nick. So what you're seeing here is our inspiration for our initial solution. Now, there is a reason why we call this an evolution, and that'll be obvious soon. So this was the original inspiration. But after this, I'm going to show you our actual implementation. We're going to go over some of the pros and cons, and then we're going to talk about how we managed to greatly simplify our solution using AWS EC2 Image Builder. I'm going to try not to go too into detail, as there's quite a lot that goes into the solution, but I will mention though that at its core, This pipeline executes using systems manager automations. Now, automations allow you to create custom workflows to configure and manage both instances and AWS resources. These can range from running a script on an instance, spinning up new instances, terminating instances, executing Lambda functions, or even creating new images. These automations themselves are defined as systems manager documents. You'll see me refer to these the systems manager service as SSM throughout the presentation, and it'll be shown on the slides like that. So to get into it, this workflow actually shows the high-level process of creating an AMI using the Golden Image Pipeline. It's a solution provided by AWS on the AWS Marketplace. It was submitted in late 2018, and it's pretty much where we got our start with learning AWS services and what we needed to do. So as a bit of background, initially what this automation does is it creates an EC2 instance, patches it, updates any libraries, and executes any of your custom hardening required for the image. And once successful, a new AMI is created. It then launches a test instance, installing Inspector or any other testing suite you desire, and reports these results. Approval ensues, and the AMI ID is published to the SSM parameter store, where it can be retrieved in plain text for building any future EC2 instances. So now here's where we move to our first solution. We'll call it the ABS Golden Image Pipeline. So the original ABS Golden Image Pipeline started off with a triggering mechanism, a CloudWatch event which delivers key information such as what operating system is being built, what hardening documents require to be executed, and what managed AMI we want to be using. This then triggers the SSM automation document, our SOE pipeline. This is where it creates an instance using that AWS managed AMI, executes any scripts on the host, applying any patches and configurations, and lastly, once this has succeeded, it creates the Golden AMI. Next is the testing phase. We start off by creating a test EC2 using the Golden AMI. Then executing any tests such as Amazon Inspector, we're able to validate the compliance and then approve this for publishing. Publishing simply involves distributing the Golden AMI to the selected organizational units or accounts in our organization. And decommissioning simply just means any image over 30 days or any specified number of days, any specified number of images, or any image not in production. Any of these parameters can be used as a combination of rules to ensure that images are properly cleaned up. Not pictured here is a lot of the other services that go into the solution. I'm sure it would take a while if I really went into the grit and details of this. So that's our initial solution now. I'm going to let Nick go into the pros and cons, and then I'll take it back and we'll go over some of the surprises and interesting EC2 implementations that we can do. So all yours, Nick.
Thanks, Isaac. So once our pipeline was operational and it was ended up being in use, all our requirements were fulfilled. So it ticked all the boxes. But not just that, we also actually did learn a great deal of how all the AWS services worked, and they all tied together. So we started on Amazon EC2, played around with the images there, and then started learning about all the different roles and policies to apply to it. Then trying to automate a few of the things with Lambda and trying to play with the roles. And then, of course, as you know, we deal with highly sensitive data, we had to encrypt it. So playing around with KMS and then playing around with policies again and playing around with different explicit deniers was fun, but we eventually got there in the end. And then we played through, then we were exposed to a lot of the other services like logging, CloudWatch, security scanning inspector, and SNS notifications. Now, as having the pipeline working was integral to the business, it was also crucial that its availability was kept high. So here lies the bus factor. So if you don't know what that is, it's when you're heavily reliant upon one person. So if something happens to this person, then you lose that support or knowledge. So for instance, in our case, Isaac had the most extensive knowledge in this complex pipeline. So we relied heavily on him to be available whenever issues arose, or if we wanted any other like new features to be added in. So also, as we're fairly new to AWS, our initial templates were actually quite primitive. And the next fact compounds that. So as we use these templates, they caused us issues as we had Lambda functions that our solution heavily relied upon, which were using these primitive templates, and they lacked effective automated testing. So where to from here? While our solution was operational, it was quite complex, and there were a great deal of moving parts that required specific knowledge with how it was implemented. So we started actively looking for other solutions that could help by simplifying this process. So we looked at Packer, for instance, but we're pretty fortunate that AWS is constantly improving, and at reInvent 2019, EC2 Image Builder was announced. So over to Isaac.
Awesome. Thanks again, Nick. So this is where the evolution comes in. We have the opportunity to make sure that all of these challenges, all of these problems, all these cons can go away. So in late 2019 at reInvent, the latest and greatest in AMI building technology, EC2 Image Builder, was something that was immediately on our radar. So what is the EC2 Image Builder service? EC2 Image Builder, a service not unlike our ABS Golden Image pipeline we showed you previously. This allows you to start with the source AMI. You can then customize the software installed on this image using a curated list of templates provided by AWS, or design your own reusable templates. This then enables you to secure your images by patching and running custom hardening scripts using these same templates. And finally, the service will handle distribution of your golden images once it has successfully been built. And this includes going across multiple regions and accounts. Right, so on the back end, EC2 Image Builder still uses Systems Manager automations to the same effect, but abstracts its core functionality away from us, so we don't have to worry about that anymore. So each pipeline actually contains one of these things called an image recipe. This image recipe decides what encryption is applied to the EC2's elastic block storage volume, what the source image will be, and what components to run. As you can see here, there are a couple components that I will highlight. The Amazon Credo 11 headless. So if we wanted to, for instance, install Java, we could just associate the component with our recipe and associate this recipe with the pipeline. And all of a sudden we have Java installed. And on top of that, these templates, these components can also define tests. So we could have a test that ensures that the binary is there once the image has already been baked. And if it's not there, then the build will fail. With this in mind, we can start to remove a lot of the infrastructure that made the solution complicated for us, and we can actually get Image Builder to do it for us instead. We don't need to schedule any CloudWatch events. Image Builder is going to do that for us, and we don't actually need to worry about how the entire pipeline runs at all now. Image Builder kind of does that all for us. I did want to note that we also maintained managing our own Lambda decommissioning function, simply because of the fact that Image Builder didn't actually come around to resolve this problem for us, and it's just easier to handle ourselves. As for distribute, EC2 Image Builder doesn't actually support sharing to organizational units as easily as we're used to, and uses Resource Access Manager, and it's quite brutish in trying to make that work with our given solution in an effort to make it easier. Now, how can we go about this? Well, we had a few mandatory asks for the new solution. We wanted CloudFormation support, encryption at rest, and VPC endpoints. We didn't want to have to ignore infrastructure as code. We wanted to make sure there's no configuration drift, and we wanted to make sure that we're keeping up with our strict security guidelines. When we initially met with the EC2 Image Builder team, none of these features were actually there, but two of them were on the roadmap, CloudFormation and KMS. Fortunately, these came out, and on the 8th of May this year, we had functionality there. So what we did was we got started on prototyping, reached out, and we found out that VPC endpoints not on the roadmap. Fortunately enough, less than a month later, on that lovely What's New page, we saw that VPC endpoint was supported for EC2 Image Builder. So this let us be able to get that idea of the solution and simply replace our existing infrastructure with something much simpler. As for the results, it was a very simple and fast migration. Honestly, all we had to do was just decommission our old pipeline and at the same time implement our new pipeline, making sure that the new images went to the same alias that the existing images did. One thing I didn't mention earlier and that I've forgotten to is that we have CloudFormation macros in all of our accounts by default. What this enables us to do is allows our users to be able to dynamically use our immutable infrastructure in the form of our AMIs, and then they can always use the latest image no matter what. And what this means is that this simple change in our centralized account meant that this would not affect any of our existing applications, even if they're in production. They would simply, just without a thought in the world, be able to grab the new image. It was also a new, easy to follow pipeline. The last pipeline was unbelievably hard to get people on board with a lot of encouragement. I must say, the new pipeline, it definitely takes a lot less time, and I mean, in a day, other members of the cloud platform's operations team can make sure they have a pipeline up and running within the day. It's also production ready. The ABS website, you would have seen that release calendar earlier on. That was on the services built by this image builder pipeline, which is really good. And then we have more sophisticated integrated logging. So what this is able to do is make sure that any of these components that are described earlier, for instance, when you install Java, any logs that come out of that will be sent to CloudWatch, and then any failures in the build, the validation or test will be shown there, and you can easily validate the progress of your image build without having to go into that box. One picture I want to show, I like this one, is before our infrastructure templates were quite massive. So we had the pipeline itself being 1,346 lines at the moment. And then if we wanted to add a new operating system, we would have a boilerplate template, and we would simply add the hardening steps and then the test steps and the instance, the AMI source that we wanted. And this would typically be around 400 plus lines, not including scripts that were going in S3 bucket, etc. What we've been able to take this down to is 167 lines of boilerplate. And this includes the whole pipeline and the image build itself. So what anyone can do is, using even just the Amazon provided templates, they can build a Windows AMI, for instance, just by deploying the same template using our boilerplate code, and then have an image built within the hour, which is very, very nice. Also, the architecture for the solution is a lot simpler to explain to people. What you don't see here is a lot of spaghetti and lines going between these different documents on the left here before. It definitely makes the solution a lot more complicated. But now after, we just kind of have to put EC2 Image Builder in there. There's the recipes and the components and a couple other pieces that I haven't mentioned, but those are very simple. You can view them in the console, and they're very tangible. And as I showed, they take up less than 200 lines of template. Last off, one of the biggest benefits for us is Amazon is now doing the heavy lifting for us. So they're doing all the work, and we don't need to worry about so much of the heavy lifting there. Any of our problems can be debugged by simply going to the user guide, and we don't have to go through our documentation and thousands of lines of code. We can also use AWS support for this, and we can also reduce the burden of documentation, testing, and implementation because we're no longer doing this. And there's also one more benefit based on Nick's mention of the bus factor. I no longer have to be afraid of buses. So I'm going to leave that to the questions now. Thanks for listening.
Great talk, guys. Thanks very much. I remember my first AWS role or AWS related role back in 2012, I think it was. I had tried to build a golden image pipeline as well, and I don't think I even came anywhere near as good as your first attempt on that. So it's great to see there's a lot of evolution in this space, and it's actually a lot more managed now, I guess is probably the right word for it. So don't forget to anybody to ask any questions if you have any questions in the Slack. While we wait for them to do that, or in Slack or on YouTube, wherever you feel like. Don't forget, these are the instructions. So I'm just kind of curious now that you've got a managed service on this, like where do you see this going? Like, do you have a wish list for where you'd like to take this next? Do you think it's pretty much finished, or any ways you can improve? Whoops, hang on a sec, sorry, I seem to have lost audio here.
Sorry, that's on me.
That's on you. Yep, cool.
Yes, still muted. So next steps, it's pretty much there. Amazon has actually been able to take away most of the work that we need to do for building these pipelines. We just need to define these hardening scripts and configurations that we like, and it's there. One of the things that we'd like to be able to integrate more, and this is probably on our side, is to be able to get those server teams who don't have familiarity with Amazon Web Services to be more integrated with our solution and be able to use it easier and not have to know anything about AWS, right? So that's the real challenge.
Cool. Doesn't seem like we've got any questions coming through. Some good feedback though from people. So I guess we can wrap it up there. If anybody does have any other questions, please feel free to ask in the YouTube chat after this. Hopefully you guys will be around for a little while to answer any that you might need. But thanks again. That was great.
Awesome. Thanks, Rob. Appreciate it.
Okay, time for our second presentation. All right. So Sean and Matt, if you're able to... Oh, great, cool. They're way ahead of me and already sharing their screen. So Sean and Matt will take us through scaling their build up and down during COVID-19. So Sean is the head of infrastructure and SRE at Style Education, a small but growing group of people who feel very strongly about improving scientific literacy and about being very, very nice to one another. Sorry, that's my dog. Harry, come here. You're being noisy. Come here. No, he's gone. Anyway. So Sean likes his infrastructure simple and his infrastructure engineers friendly. Here we go. You just had to come and be a part of it, didn't you? All right. I lost where I was. That's all right. Oh yeah, so Sean's a Brisbane refugee and he's been slowly fleeing down the east coast of Australia to finally settle in Melbourne. There's no more east coast for Sean to go, so hopefully he stays here for a while. But there's always Tasmania here is quite lovely too. So that all out of the way, everybody's sharing. Let's just switch over to Sean and to Matt.
Great. Thank you very much, Rob, and thanks, Isaac and Nick. That was rad. I'm going to talk about how our little edtech company scaled up our stack during COVID and obviously the ensuing lockdown and move to remote education, and then how we went about scaling it back down again very, very quickly so as not to bankrupt our poor little company. My name's Sean O'Keefe. That's me. You can contact me here at this email address. This is my Twitter handle. Please do not go to my Twitter. There is nothing good there. Avoid, but feel free to give me a shout out if you want to chat about anything we talk about in this presentation. I'm the head of infrastructure and SRE at a company called Style Education. That's us there. Now, we are an online education company, but we like to call it blended learning, the thing we do. So this is basically a really clever way of saying our site is made to be used by the teacher and the student together during a class rather than, say, setting homework that's going to be done remotely. The thing is, this model can really easily be adapted to remote learning as well. I'll ask you to remember that fact, as that's going to become really, really relevant, as all of you who've kind of been watching the news would know. So as a company, we have a bit of a problem that we're in education and most of our users are in one geographical location in Australia. All of our customers have school holidays, so that means that every 10 weeks or so we have close to no users, and we basically get to pretend that we're a startup again. Having no users is cool in a way because it means we get to get a lot of work done, and that's great. On the other hand, it means we basically have no visibility into the performance of like new changes that are coming in, and that's really, really bad. And historically, we've had a bit of a problem with outages happening at the start of the term, when we obviously bring out new work or like new features that ship during the holidays, look really, really good with no load, and then start to have problems once everyone comes back. And lastly, due to how our sales cycle work, we do have a whole bunch of new users that land at the start of term one every year. So let's go through a little bit of a story. We're going to go to the start of 2020, and this is like, before this number like would turn your set your blood running cold. We're going to go to term one. And this is basically no different from most of the term ones for us each year. What we did, we came into a new year not being completely clear on like what our new user count would be. We had a rough idea based on what sales were telling us of like, was in the pipeline, what had come up, who had left us, but mainly like how we'd grown over the last year or so and who was going to be landing on the first day. We addressed points we expected like a small increase in load would cause, and we carefully managed like the risk of new features that we added over the holidays. So I was only have a few really big performance affecting changes landing at the start of term. And mostly we counted on auto scaling. And this is basically our main strategy for handling that new load that comes on each term. And it's a big reason that we, anytime we do succeed at the start of term, it's usually because of that auto scaling. Now, we really hold ourselves to the highest of standards with high quality imagery at Style, and this is no exception. This is my architecture diagram of how our auto scaling works. Basically, Thanks. Basically, each of our auto-scaling groups has, on each of their servers, which you'll see here, like each of these ones labeled backend, have a little square that says AP. That stands for Autopilot, which is our auto-scaling service. It's basically a cluster of containers. They elect a leader on console, and that container is basically responsible for constantly talking to Prometheus. To the uninitiated, that's a metrics server, which basically slurps up information about holistically how our stack's going, how much CPU's in use on the back ends, or like on EC2 instances, what size our message queue is at, and basically gives feedback to Autopilot saying, hey, your servers aren't keeping up, I need more, and then AP actually does the auto-scaling. That's all self-contained within the auto-scaling group. We don't use CloudWatch mainly just because we were already on Prometheus at the time, and the sort of delays of metrics appearing like or being available to Autopilot were going to cause a bit of a problem for us. So this is basically what it looks like. Autopilot makes its decisions based on like a collection of different pieces of information. For backend servers, which are primarily just handling user requests, it's mainly around CPU. But we also do things around like MySQL connection pool time, pool size, and we also just schedule like certain limits that we want to, certain levels that we want to hit at certain times of the day. So we scale right up to a certain size at the start of the day just to accommodate that sort of sudden stress of many, many users logging on at the start of the school day. So this handles two things really well. It kind of handles that fine scaling of going up and down during the day as our load increases and decreases, but it also handles that coarse scaling of our users going up over time. It just keeps adding servers for us as the load dictates. So term one, how did it all go? It went fine. We got to the end of term one. This is around March. No serious outages or problems, and it seems like everything was going to be fine. Fine in March of 2020. Now, it was around this time everyone started talking about CORVIDs or some such, but we weren't really paying that much attention. We were just too busy celebrating. And then Democracy Dan appears on television wearing his fleece, and I think all the Melbourne residents, Victoria residents, or residents of Australia, I guess, are really going to know what this meant. It meant that basically 2020 was beginning in earnest. Now, for us at Style, we kind of had mixed feelings about this. It's like, on one hand, much like everyone else as a workforce, as regular citizens, we faced a lot of challenges. We were going to be switching to full remote. This is obviously in reference to the lockdown and move to remote work. We couldn't see our workmates, and there was also just a lot of worry about what was going to happen to family and friends. Now, on the other hand, this kind of presented us like, I guess, a bit of a unique opportunity in terms of our transition to remote, the state and other states' transition to remote education. It was a big opportunity for us to do a lot of good for a bunch of kids who are going to be doing it pretty tough over the next few months. We were already in a lot of schools, and we had the potential to do a lot more than we were already doing for schools as it was. And it was also a great chance for us to bring on a bunch of schools that weren't familiar with Style and kind of help them, one, get through the lockdown, but also then potentially have them go on with us to continue using our product. Now, on the third hand, we were going to have a lot more users. We usually run on a good day about 10,000 concurrent users at our peak. We kind of hit our sales numbers and had a look at what we reckon we were going to see for the lockdown, and it was going to get us somewhere between 50 and 80,000 concurrent users each day. To make matters worse, our CEO did this, which for those of you who can't see it, is basically telling the entire nation of Australia that they may use our product for free. And I'm guessing with this kind of came an implicit guarantee that our site would not fall down and catch fire. So we're good, right? We've got auto scaling. What's the problem? The problem when we're going to add this much traffic to our product is bottlenecks. So when you're talking about scaling, you can make reasonable assumptions that a small increase will probably give you at worst a small linear increase in resource usage with user increase. But at a certain point, you're going to hit a nonlinearity. Now we're back to my masterful diagram drawing. This is our system architecture. It's a bit more sophisticated than this, but there's only so much you can do with textures. And what you can really see here, there's a lot of sort of coupling and interaction between different things that are attached to ASGs. Now, our primary application is our backend, async, and SSE ASGs. These, obviously, if they were just simply taking a request and responding, could scale infinitely, basically. The problem is they do depend on central points, our databases, our caches, which isn't listed here, Console, which we use for service discovery, and as I said before, Prometheus for metrics. And there are often two-way relationships between these. So what's going to happen essentially is the risk we run is that our backend server is going to merrily scale, as you can see on the left here. And in a good situation, they're going to reach out to a third thing, which isn't scaling with load, and ask for a resource. In the great situation, it kind of goes up, basically does not increase with server count. Servers all use a common resource. For example, it might be many servers only create or subscribe to the same queue on a message queue and don't need many, many, many queues, or one queue per server. The bad situation is when each time we add a new server, it uses new resources on that sort of central point. And that can basically mean that your resource usage on that dependency is scaling linearly with your system usage, which is a problem. So your server count, which is a problem. So you can see here there are a lot of things where, for example, our backend auto scaling group is going to go up and put more load on console. It's going to be making more requests for information about services as these new backends go up. It will be Prometheus will be pulling more and more time series from each of these servers as the number of servers go up, so do the number of time series in Prometheus. So while we can merrily scale up all of our ASGs, the big issue is, can all these other servers handle the load? So what do? Do we basically just make it so these things are all okay? The problem is we don't really know which things are going to run out of resources and which things are actually going to be able to handle 5 times as many backend servers. It's really hard for us to see the system at the expected usage because we don't have 80,000 users, and we won't until we do, and then it's going to be too late. What more is we've just gone into the holidays at the point where the lockdown or the school remote education has been announced. So we don't even have a way to really see what new change is going to be like with our existing user counts, let alone the new levels. And the biggest constraint is that we have 3 weeks to get all this done. So obviously we go on and just do full synthetic load testing. Absolutely not. We only have 3 weeks. And fundamentally, we don't really believe in full synthetic load testing at style. We've had a few cracks at it. Basically, it's very, very hard to maintain a set of load suites unless you're putting tremendous energy into it. We're a small team. And I think it's very, very hard to really be as much of a sicko as your users are going to be when they use the platform. So instead, don't laugh, we doubled the size of everything. So we basically took our Prometheus instance, our console instance, our MySQL instance, Mongo, everything that was basically a downstream dependency, and just said, at the end of the day, the cost of money is small, the cost of engineers is high, and the cost of an outage is the highest of all. We didn't want to get caught flat-footed by just under provisioning one of these third-party things if all of our architecture was actually fine. So we just basically looked at what the cost of actually doubling everything would be, brought that number to our C classes. They gave it the tick, basically said, we are willing to spend that much money to at least partially mitigate the probability of having an outage when this all kicks off. Next step was we basically guessed what we had to do. Now, our sales team know roughly how many people are going to come on. They know how many users we have with subscriptions and what sort of usage rates that we have at those schools. So we might say that a school that only 10% of the students use it. Worst case goes up to 100, or best case, whichever part of the organisation you're in, goes up to 100% of usage. Likewise, we might have schools that are just coming on, that are trialing it, that may go up from not existing in our numbers to being, let's say, 10% usage. We can use this number to put together a rough idea of how many, the maximum concurrent usage we're going to expect on the first day of term. And we can just translate this into a worst case scenario where the number of servers we need goes up linearly with that. And we ended up roughly with something like about double or 3 times the number of servers that we were going to need. And we basically just scaled up to that. We just set autopilot to go up to that number every single day leading up to the actual outage. Now, the reason for this isn't really realistically trying to predict what happens under this load. This is about simply saying, do we exhaust resources when we go up to that server count? Do we spin up a whole bunch of backends and they just completely use up our entire connection pool on MySQL? We want to find cases where just something really, really dumb happens, where just that static resting resource use without even usage blows up one of our downstreams. And believe it or not, we did find a ton of things to fix just by doing this one cool trick. So what do we do next? We go on to our more scientific approach. That's a lie. We didn't do anything scientific. We basically did a process that we like to call at style a feelings-based bottleneck identification. So we basically worked off our understanding of the architecture, And also, most importantly, past outages. The outages that kind of made us think this particular part of the stack is under stress. This thing seems to be the first thing that goes when our load upticks. And we identified a number of systems that we had to do very limited load testing on to see how they would do. The main one we really picked on was RabbitMQ, and we're actually quite happy with the method we used to load test this guy. Rather than having to dump a whole bunch of load at the front end of our stack and end up with somewhat contrived sort of conditions, we did something that we call traffic duplication. It's a fairly common, well, no, we don't call it, everyone calls it that, but fairly common method. What we did basically was we have a common client that our entire stack uses to send messages on Rabbit. We basically added a little option in the API for this client that says you can just basically duplicate a request that's going into Rabbit, and then the consumers from the message queue will then check whether that flag's set and delete it, not actually propagate it forward. So it is only putting load onto Rabbit at the point where we touch the message queue itself. It does not send any traffic on, or at least doesn't add any send any duplicated traffic onto the rest of the system where it might get written to databases in transactions data idempotent or something problematic like that. It only loads up Rabbit, and it also accurately models our traffic in the respect of doubling it or maybe timesing it by 1.5, because all the downstream events will still fire on Rabbit. So if one Rabbit message triggers a second Rabbit message, both of those messages will still be duplicated. And it gave us a really good picture of what Rabbit was going to do, and led to us doing a bit of work in sharding queues so that we could actually handle the traffic without things bogging down. And last of all, we just had to think, what if we couldn't actually guess what was going to wrong? And facing it, with 3 weeks' time, there wasn't a good chance we were going to get it. We basically just did a whole bunch of work with the rest of our time on load shedding. Now, the main thing we did, we have a tiered SLO. So we basically treat work that is enabling students to do work in class as the most important work. Secondary to that is work where teachers do preparation for classes, or say mark work that's been handed in by students. It's stuff that is important to teachers, but not necessarily urgent. The big thing that we try to avoid is having teachers in front of classrooms where they can't actually teach a lesson to people. So we kind of mark all the in-classroom stuff as L1. We mark all the important stuff that isn't time sensitive, and that as time sensitive as L2, and everything else that we could kind of lose and still have an okay style experience as L3. Now, we basically labeled all of those routes as such in the actual, we use a protobuf API, so we send protobuf messages around from our API through to the back ends and then through to Rabbit to the async boxes. All messages that go through were labeled with their level, and we actually just created number switches that would drop L3 first and then L2 traffic if we dialed it up a bit, to slowly degrade the service so that we could at least, if something did go wrong, stay up, debug the problem and potentially fix it without experiencing full downtime. Another obvious choice, or well, not obvious, we really did kind of agonize over it a bit, but it's kind of what we had to do was have the option to drop unpaid users, people who were trying the platform. This was based on the bet that essentially people would be trialing this over the period. Maybe a limited number of people would be using it in earnest, but most likely our new unpaid customers weren't going to be really depending on us. They were just going to be using it in a limited capacity. And last of all, we picked a whole bunch of routes that were very important for work, but also quite expensive and maybe a little bit too busy. And just basically set it so that primarily our autosave routes, which are expensive writes, but at the same time we could dial back and still have a fairly good experience. So basically that users would be tapping away at their work, and if they did suddenly close their browser, they'd just get a warning that, hey, you can't navigate away, we're still saving. That would take a few more seconds than usual, and then they'd be able to move away. So using all that, how did it go? Monday, the first day of term, was great. I think we're up to around, say, 50 or 60, or just a bit under 60K users, and everything went, a bit less than that, about 35 to 40, because this was the day where only half the scores had come back, and everything went swimmingly, not a hiccup. And then came Tuesday. And we basically identified an issue where the one big sort of outstanding problem we had was that if we really did get to a very high MySQL connection count, we did have problems with load and potentially MySQL restarting. And so we basically decided we weren't going to do deployments during business hours, just to avoid that problem altogether and not run the risk. Now, on the Monday night, one of our developers had identified an actual bug that we'd shipped on Monday, and he put in a fix for it. And this landed basically, I think, Monday morning around about 7 a.m. Now, the on-call developer at the time, our on-caller at the time made the call that it was going to be able to get it out on time. It was important enough to try and ship it. So he pulls the trigger then. And things slowly start to get worse. It's at this point that our entire RDS instance has basically restarted, and it's not only restarted, it's completely corrupted itself and additionally corrupted our replica, which was our backup method at the time. Now, we actually were down so hard that we received this message. Now, we haven't actually been on New Relic for about 4 years, but our site was down so hard that an old alert that we had there fired for us. And this is how we knew we were really in trouble. Now, the problem was basically a massive MySQL error count, which I've kind of shown in this slide here, but then redacted, not error count, connection count, which I've redacted in this slide. It is just genuinely embarrassing. We were previously a microservice. We actually rolled back from being a microservice into a monolith, and basically took all those pools and kept them separate, which meant that as we scale our stack, each of these instances were taking up massive numbers of connections. And this combined with a problem with, I think, the version of MySQL we were using, keeping temp files open even after they were no longer used, meant that we completely ran out of disk and crashed. And that was basically our outage. I'm not going to go into that because that's not really the topic of the talk, but just talking about the measures that we did take, the things that really, really went well was that our load shedding, after we got our MySQL instance back up, and we're actually experiencing troubles with it for a while afterwards due to, I think we took some dud advice from AWS support and bumped to a different version and enabled a different config thing, which actually kept us down for another day as we managed an issue with load as a result of that. Our actual load shedding let us stay up for the majority of that. We dropped a lot of our less important routes and some of our users and managed to at least keep serving the site while we worked things up. Also, our message queue with the fixes that we put in place actually worked admirably. The big issue that we kind of had was that you can't just shed load. You really need to have a communication strategy. We shed this load and we're very proud that we kept the site up. But it was really for naught because it made a lot of our users really, really angry because students could actually do their work because we kept their routes working, but we actually cut a lot of teachers off with our load shedding, and we didn't actually have anything that pops up on the site that says we're actually shedding your load so your students can keep work. They just saw errors. We hadn't actually done any of the front-facing stuff for it. We didn't have something like a status page, which we now have after the post-mortem, or a way to actually communicate to teachers what we were doing. So in fact, we could have just gone down and had probably as good a sort of effect on teacher trust. But it's something that we've rectified now. We have really good messaging when we're engaging those feature switches and have done a lot of teacher education. For those of you who want to actually know a bit more about the actual incident and what happened, that's the link to the CEO's instance report. And that's pretty much me. Now I'm going to hand over to Matt, who is our SRE practice lead. Basically, this whole thing, it was my job as the head of the department to basically scale these instances up and spend a ton of money. Matt's day-to-day job is to always undo all the scaling up that I do. And he's really, really good with it. So I'll hand over to him and let him finish up the talk.
Hi. So I'm going to be talking about how we scaled back down. So by about mid-May, when we'd kind of hit our peak usage, our AWS bill had basically been replaced with a money fire. We'd been throwing it in the money in the fire pit to keep our site running. But what was happening was we were starting to see users going back to school. Some states had kind of finished remote learning and were heading back into in-person learning, and we were starting to see some of those numbers dropping off. So you can see kind of this downturn here. So our problem was we still had this quite high AWS bill, and the CEO came to us and said that there was a kind of big financial risk for us to be running such a big bill to maintain the site that with 100,000 users using it each day, but when really we were scaling back down to kind of more our normal load usage. So we needed to cut our bill by about in half, and we did it. And so I'm going to just talk through kind of some of the measures we took in order to kind of bring the bill back down and get it back to kind of a new COVID normal. So a bit more than what we were doing in kind of the start of the year, which is always a bit light for our AWS bill, mostly because no one's really using the platform and kind of adjust to this new level of usage with these new schools that had kind of stayed with us after COVID had finished. So we've begun by scaling down our database. After the outage, as part of kind of our remediations from the outage, we'd scaled up to a 24x large, which is, I think, the largest we could get in that database class. But that was costing us about $700 a day and about 34K a month. So we had to scale that back down. But the problem was we didn't know what issues we'd run into when we were scaling back down. Would we hit those temp file usage problems? Would we hit connection count issues? Or would we really just scale down lower than kind of the application servers were putting load onto the database? So what we did was we only scaled down under load, and we really took our time. We were willing to pay extra money to buy ourselves more error budget after the outage. We didn't want another kind of repeat of that big outage again. So we were really went down one instance size at a time over a kind of a period of weeks until we kind of got to a level that we operated at for the rest of the year and has been going really well for us. So during the outage, we were worried about instance reservations, and just during COVID as well, a lot of businesses were moving online and starting to use up more kind of spot capacity. So we switched to on-demand. That was something we were able to roll back really quickly, and that saved us about $20,000. So you can see in the Aqua here that we were really able to get a big saving there. But we kept our database quite large, so that was still a big chunk of the bill. So there were some other savings that we were able to find. We went and looked at the assets that we were serving when users were loading the site. We added compression to those, and so we minimized the bandwidth that was being transferred to each user. And that was one of those things that when you only have a small number of users online, you don't notice as much, but as you scale with the number of users, that was starting to really become one of our larger costs. So another part of scaling down for us was autopilot. We didn't want to underscale, which is always a danger when you're trying to save money. We really wanted to make the trade-off of still spending more money than we needed to make sure that we were meeting our SLOs and weren't going to kind of have another repeat outage. But the beauty of autopilot was in the morning, we could scale up to a large number. So here we're scaling to 50. During that week, we were able to scale to, say, 70 instances at 9 a.m. And then throughout the day, autopilot would scale back down, but also be able to scale up if it was getting more users coming onto the platform throughout the day. And what we typically see is our biggest amount of usage is at 9 a.m. and then it starts to trickle off throughout the day. So again, we needed a tool that was going to show us where all the money was being spent. We'd spent a bit of time using Cost Explorer, but we really wanted to dig in to kind of find some more savings. So one other we'll get into kind of how we got into those kind of fine details. But another big saving we did was looking at Redshift and applying more compression there. So really going and finding any data that was being written by our users and kind of into downstream services, trying to compress it. So we'd used Cost Explorer before. If you've used Cost Explorer, you'll know that you're able to search by tags and break down into groups of cost line items. But what we really wanted to do was to be able to export this, run some queries, and be able to kind of get down to that fine-grained granular information. Which instances were costing us money? Which auto-scaling groups? And so the tool we used for that, after playing around with Excel spreadsheets for a while, we found that they were just hard to reproduce, and especially when you downloaded a whole new spreadsheet, you had to go and reapply all those formulas. So we looked at kind of Athena. And Athena is a serverless SQL database that works on your S3 buckets. So you give it a template for the kind of data in an S3 bucket, and then you're able to query that using SQL just like you would a normal SQL database. And the great news is Amazon provides a billing bucket with each individual line item of what was actually costing you money. So the bucket looks something like this. It's a large amount of CSV files. You can download them and process them manually. But with Athena, we were able to write queries. So the beauty of this was the queries were reproducible every day. We were able to rerun them and get new results and track them over time. So the queries end up looking something like this. The tool that we used for running these queries was called Looker. And we were able to build this dashboard. So this is our cost tracking dashboard. Up the top, it's got our kind of how much is the bill costing this month. And then it gets into kind of some of those more granular details that engineers really care about. So usage type over the last 2 days. What usage type is costing us the most amount of money? You can see here, it's our C4 2x large instances. And then we're able to click on that and see exactly which instances were costing us that money. And this is great for when new costs pop up. You're able to see them really quickly and get a lot of visibility into them. Savings plan usage, being able to see how much savings plan reservation we have for our instances versus the overall cost of non-savings plan covered instances. And then down the bottom, in this cost function by day table, what this is for each day broken out by each area of the stack. And so this kind of gives you a broad overview, but lets you track it down to those categories and track it by day. And when you click on one of these columns for a single day, you get a view that looks like this, which has, you get a view that gives you a detailed and granular breakout of where exactly those costs are going. And we'll look at that in a minute when we look at how our NAT gateway costs were starting to rack up and how we digged into those. But another thing the dashboard was really great for was showing us how where our untagged resources usage was going. So we'd obviously have a lot of our resources tagged, but there are some resources in AWS that are hard to tag or you can't tag. And really being able to see which instances weren't tagged. So this tells you that there's an M5 large and actually gives you the instance ID. So you can go and look at that, find that instance, add the appropriate tags, and get that going towards the right cost area back in this graph. And then for some things like reservations, you can't actually tag them, so being able to see exactly what those costs were. Another resource we used were tag policies in AWS, which were able to tell us which instances weren't tagged until we could go and apply tags to every instance in our account. So getting back in to this dashboard, being able to get down into this granular level really let us iterate quickly on scaling down by being able to track each day what the differences in costs were. So the big one for us a couple of months ago was network costs. We're starting to see these start to skyrocket. And so we really dug into where this money was going. So we got our AWS bill, and here we've got which instances and which NAT gateways and the actual IDs of those instances. So really being able to track back to which resource was generating this cost. And so we came across this, which is the per gigabyte data processed by NAT gateways fee. And then once we did kind of some searching, we found this. So Corey says, that there's a line item buried under EC2 on your build called Manage NAT Gateway Data Processing. And this can become a giant number, but with a little bit of work, it can become 0. And it's charged in addition to data transfer cost. So if you're being charged for data transfer to the internet, you're also being charged for this on your Manage NAT Gateway. So you're really copying that twice. So we started to dig into what is a NAT gateway. Well, it's a way for servers on a private subnet to be able to access the internet, but it prevents the internet from initiating connections back to those instances. So a NAT device forwards traffic from the instances onto the internet, but adds the source IP as the NAT gateway. And then when the response comes back, it modifies the message to say the destination IP was coming from the NAT gateway back to those servers. So really, it passes on the message and it receives it. So we looked at this, and there was really no way out of that NAT gateway fee. There's nothing you can do to configure it to turn that off or minimize it. So we looked at what were the alternatives. What we came across were NAT instances. NAT instances are just a normal EC2 instance set up with some IP routing rules. And those are essentially performing the same function, but there's a trade-off. And the trade-off was that NAT gateways are highly available, which means that if one of them goes down, another one automatically gets promoted back up. But with NAT instances, you have to manage that promotion yourself. You typically use a script to modify the routing table to promote a new instance up to be managing traffic for that subnet. But there's quite a considerable cost benefit. You get rid of being charged that additional managed NAT gateway fee. And so we looked at this and we went, it's probably not going to work for our production VPCs. We need those to be highly available for our app to be able to serve requests. But it was really applicable into our CI accounts and our development accounts, which do a fair bit of accessing the internet to get different resources. So we were able to replace the instances in our development and CI account, and this saved us about $3,500 a month. So thank you very much for coming along and listening to me and Sean. This has been a bit about how we managed our COVID scale up and our scale back down. If this sounded really exciting to you, we're hiring at the moment, so come and have a chat to us on Twitter. I'm at Matthew Borden, Sean's at Euromilk, or get in touch with us through styleeducation.com.
Oh, thanks, Sean, and that was an awesome talk. Gave a lot of insight into how scale up and scale down is definitely a very important part of that. So while we've got people frantically typing more questions, we got our first one from Drew, who wants to know what you used for the actual dashboards.
Yeah, sure. So we used a tool called Looker. It's recently been bought by Google, but it's a generic BI tool for being able to run queries on like just normal SQL databases, but it also integrates with Athena. So I'll go back to the article and I can post a link to this later. AWS has some really good guides for setting up Athena on your AWS on your S3 billing bucket. And then Athena was just being linked into from Looker, but you could use any kind of SQL visualization tool, or you could just run the queries with a kind of generic SQL client.
So a question from somebody called Rob. Looking back to your efforts to scale up for COVID traffic, is there anything you would have done differently?
Look, honestly, we're happy with most of the stuff we did. The MySQL stuff was on our mind, and I think we kind of really just been lulled into a bit of a trap that it really had been quite stable for a long time, and we'd been pushing it and pushing it, couldn't make it fall over. We knew about us having too many connections. We saw the graphs, they were horrifying. We just kind of like stack ranked all the stuff in terms of risk and impact, and while the impact was very high for MySQL, we didn't really rate it up there as being likely. And that really stung us. We even had rumblings, I think, the week before where like it did have a little bit of a hiccup. I wish we'd gotten on top of that. But honestly, besides that, all the stuff we did, we kind of saw down the track that it was meaningful. Doubling instance sizes for a lot of stuff seems silly, but we actually had trouble scaling a lot of those back down. They really were being utilized correctly after we hit like 60K concurrent users. So by and large, we're fairly happy. And I think honestly, one of the other big take homes is when you're having an outage like that and it's very complicated, do less. We definitely kind of got a bit down in the mouth after about 3 hours of downtime. And we got this advice from AWS about switching a configuration option. And it was that configuration option that really did sink us. The next day or so, we were having performance issues because of it. And it took us a long time to roll back. Really just take it slow, talk through your decisions with your on-call team, and yeah, just one step at a time.
Awesome. Thank you. I don't see any other questions at the moment. So I think that then just leaves me to thank you both very much for this fascinating talk. I really enjoyed it, and especially considering the type of workloads we ran. It's very appropriate. Well, and I hope that in the that some people can learn from this, because I did. So thank you very much.
All right. Yeah. Thank you very much.
Thanks, Dave.
Great. Thank you very much, Sean and Matt, for that talk. Like Ian said, that was actually really insightful. You don't often get to hear from a company that actually faces an event like this and the steps that they go through. You see a lot of advice come from Amazon and from other CSVs out there that want you to help with that sort of stuff, and buy their product most importantly. But to actually hear real life experience on the things you tried and how you approached it, I think that's very valuable for a lot of people. Okay, let's wrap up for the evening. So our next event is to be advised. At this point, we do have some plans that we're working through for next week for reInvent, or the next 3 weeks really for reInvent. So please stay tuned to our Twitter and our Slack for information on those. Otherwise, we will be back for January, whether that's in person or not. We don't really know yet. We'll find out soon, I guess. A huge thank you for throughout 2020 for to all of our sponsors, so Enable AC3, CMD, and Do It International. That we couldn't have done this year without you guys. We really appreciate your support and your assistance throughout this year. We look forward to talking about 2021 very soon. And finally, we have a Zoom virtual drinks event that comes up right now, and I'm just about to post the link for. Link is posted. So if you are hanging around for a little bit, please feel free to join us on Zoom following this. Otherwise, thank you very much for 2020. We'll see you next week and the week after for some reInvent activities. But otherwise, have a great Christmas, happy holidays, and a great New Year. We'll see you in 2021.